Hey friends, thought I'd make a quick video about this week's participatory assignment. If you weren't here, you'll definitely find this useful. If you were here, I think maybe quite a few groups kind of missed some key things that I wanted you to think about, so I'm going to drive that home right here. First thing, here's our diagram of the room. Now this is of the room 4337. The back wall is 30 feet. The width of this room right here is 27. But keep in mind we have this little jet out right here. So we need to be aware of that because you can't just assume it's a big rectangle, right? So the measurements here, 5.5 feet on that little jet out by 3/4 of a foot. 9 inches, I just put everything in feet. I called it 3/4 or 0.75 if you will. All right? Now, 30 minus 5.5 gives us this remaining front wall, which is 24.5 feet. Okay? So all the windows here, we have two windows that are the exact same. They're 3 feet wide by 10 feet high. The door, I'm going to assume, also is 3 feet by 10. The door is actually a little bit bigger than 3, but we can round using the principles of rounding and estimation. And the windows over here in the wall, I'm going to call that 26 feet by 3.5 feet. 3.5 feet high, but it doesn't quite run the whole length of the wall. There's about a foot here that it doesn't, this is the corner. The window doesn't go that far. Now, if your measurements when you did this on Friday are a little bit off, that's okay. This is kind of plus or minus 10%, all right? So if you measured a little bit more accurately than me, that's awesome, right? You're even better off. So a couple of things based on all this that I wanted you to think about. Number one, including the windows, we have to find the surface area. Now the length, width, height, you can just fill that right in. Remember, we're assuming a height of 10 feet in this room. To find the surface area now, we're basically going to take every wall and figure out the area of that wall. So starting here with this wall, we know the length of this wall is 30 feet long and it's 10 feet high. So when we multiply that out, 30 times 10, and again, we can just use that little multiplication trick that we now know, right? Just move the decimal one place to the right when you're multiplying by 10. It gives us 300 square feet for that wall. We do the same on this one, 26.25 feet long, this wall, 10 feet high, you multiply it out. Same with this wall, 5.5 times 10. Same with this wall, 0.75 times 10. You guys get the idea. It's basically every measurement here times 10. Okay? Now, the thing about the floor is it's not an actual rectangle. So here's what I did. I drew an imaginary line right here. Okay? And basically I'm going to call this one rectangle and this another rectangle. I'll find the area of this one and then I'll add it to the area of this one. So the area of our larger rectangle was 24.5 times 27. That gives me the area here. And then the area over here is 5.5 times 26.25 feet. All right, and again, your numbers, if they're a little bit different, that's fine, but that's basically what we're doing. So here's the big rectangle. I added it to the little rectangle. We add the area, and that gives me the area of the floor. Then I doubled that number because we have to include the ceiling as well. Okay, so that's where this number comes in as well. So don't worry about my numbers, worry about the play. That's what we would do. For the second part of this, I want you to actually exclude the windows. So again, a couple of the walls are going to stay the same, right? This wall has no windows, this little piece, this piece, this piece, they're all the same. You can just do those again. The ones with the windows, what I want you to do is to take the area from question 1, from the first part of this, and then subtract the total area of all the windows and doors and all that stuff. So for this wall here, we know that the area of this wall is 262.5 because I multiplied it by 10. And then I'm basically just going to subtract 30 plus 30 plus 30, or 90. All right? And that will give me the area of the wall, excluding all the windows and doors. Do that for the other wall as well. Keep in mind, you also got to include your ceiling and floor, but again, you can copy a lot of that over, and that's going to give you your second surface area. Okay? So that's kind of the play, what I wanted you to think of. Okay, the third thing that I just want to point out, basically when you calculate the surface area to volume ratio, I want you to take the surface area, I want you to divide it by the volume and get me a number. Take it to a decimal. And take it to a couple of decimal places. This is a pretty precise measurement here, and it's going to give you some insight, hopefully, for the last couple of questions. So number 7, is there a significant difference between including the window or excluding them? So when you look at the surface area to volume ratio between the two times that you calculated this, is it a significant difference? Why or why not? And did anything about this surprise you? Explain. Now when we're talking about surface area to volume ratio, what we're really measuring here is efficiency. This room has been designed to be efficient, an efficient use of space. And in fact, every room in this campus has been designed. That's what engineers and architects do. So kind of thinking about that, explain your case a little bit. You can make the argument either way. I'll leave that one up to you. Okay, so if you have any questions about this, make sure to email me. Let me know tomorrow in class. It's due Thursday at midnight in the Dropbox. Thanks.